Maybe make it a little bit easier, I'll turn the lights out. So fall asleep on me or I'll turn the lights back on. And can you just use it in that group or maybe somewhere else? Alright. Man, it sounds like we're dead in here. Y'all know that you can talk and actively collaborate, help each other think. Or you can sit there quietly and bored. So 0, 0, negative 3, 0. That showed up for a handful of us. 0 and negative 3, two most important points of the x-intercepts, the roots. All right. So it looks like pretty much everyone's agreeing to the same ideas. So let's quickly look at this. So this is, I think, 144 maybe? Does that sound right? Yep. So tell me when to stop to find the point that you're referring to.
Stop.
Here? Okay. And then a lot of y'all reference multiple.
Right there.
Right there. And so I want y'all to notice, and keep this in mind, because this is an important part of today's lesson to practice these skills. Realistically, where should we focus our attention? Because when we had this function yesterday, there were a whole bunch of points that we could have looked at, right? So where do we want to focus our attention when trying to dilate one linear function by another linear function? Around the x-intercepts. Now the vertex is going to be in between your x-intercepts. Notice it's literally the average of the x-intercepts. But I'm going to focus my attention around the x-intercepts. Because what's another word for those x-intercepts, or for the x value of those x-intercepts? The roots or zeros. Because remember, and I referenced it in the question, is where it changes from negative to positive. Hey, what number is in between the negatives and the positives? 0, right? So it's important to recognize that where it's going to change from negative to positive or positive to negative is at the zeros, also known as roots, or on the graph their x-intercepts. What are your questions at this point? Seem okay with that? So we want to focus on that idea. And one thing I do want to emphasize, and we're going to come back and talk about this later because we still need to wrap up this page. But we talked about this part yesterday. Thinking about the linear factors, right? Thinking about the linear factors, why were all of these values for the quadratic negative? All of these values are above the x-axis, so they are positive. All of these are below, so they are negative. Okay, so why does that give me negative values for the quadratic? Say that one more time. A positive times a negative is a negative, and what were we doing with those linear factors? We were multiplying, right? A dilation, don't forget, is a multiplication. And so we need to hold on to that, and that's going to be an important part of getting through the rest of today's lesson. Now, as we just said, the most important points to focus on are those zeros of those x-intercepts. So let's look at one more quick question, poll question. So I'm going to stop that poll. I'm going to start this poll here. Alright, so the zeros from the dilated function j of x could be found by, and this is a multiple choice question. So I want you all to answer that question, look through all your options. If you need to, talk it out with your small group, make sure that we all are in the same spot. Anthony, did you grab a calculator?
Oh, no, my bad, my bad.
You might want that.
Way about it.
Same, that's what I'm thinking. But in energy and talking and physically. Okay, so we got some people already starting to talk, or not talk, but answer. Actually, I'm going to take this off for now and let you all answer a little bit more. Make sure you read all your answer choices. Okay? I'm about to show the answers of others. Alright, so most people have answered by now. The zeros in the dilated function j of x could be found by looking at the x-intercepts of the two linear factors, setting the two linear factors equal to 0 and solving for x, thinking about the linear factors as x minus r1, etc. from the factored form, or D, all of the above. So, could someone, well, we only have one person, for someone who put B, or for the person who put B, could you share with us what you mean by that? And don't forget, they quickly change it.
Oh, sorry.
I don't know why you all scared. So remember what it was x times negative x plus 3.
That's so funny.
So there's the first linear factor, right?
Yeah.
There's the second linear factor. I mean, look at B, set the linear factor equal to 0. X equals what? No, so remember,
Equals y. Oh.
well, so the original function, the line was y equals x, right? But what does this say? Set the linear factor equal to 0. So set that x equal to,
0.
was that one of my roots?
Yeah.
What about if I do negative, and so remember that's y equals a negative parentheses x plus 3. Okay? Can I set that linear factor equal to 0?
Yeah.
What would happen when I solve this equation? What could I do? I can distribute, cool. You don't have to, you can also use inverse to solve, but now what?
Add 3.
Okay, so I can add 3 to make a what? Do not forget, when we add or subtract, we're trying to make that 0. And so 0 plus 3 is? 3.
3 equals negative 1/8.
Okay, so negative 1x.
And then divide by negative 1.
Or
Divide by.
or multiply by the reciprocal.
Oh,
Or,
minus 1.
this is one of those special cases, what's a negative 1 times a negative 1? Positive 1. Remember, and this is why you want to think about those identities. We want to make a 0, or we just want to make a 1 when multiplying, right? That's another way to make a 1. And so yes, you can divide by negative 1, you can multiply by the reciprocal. Either way, negative 3 is equal to x. Hey, was that my other root? So is B an option? Oh. Huh. A, we already know for sure. Did we look at the x-intercepts of the linear factors on the graph?
Yeah.
So A definitely works, B definitely works,
C works.
C, so I can rewrite this as, right, negative x minus 0, we talked about that yesterday, x minus 0, the same thing as x.
Mhm.
And then that would be x plus 3. So R1 would equal 0. R2 would equal,
3.
close. Be careful.
Negative
3, remember I need that inverse.
So it is all the above.
What do y'all think?
It's all the above.
Is it all of the above?
Yeah.
Yeah.
Do all three of those work?
Yes.
You need to hold on to that and pay attention to that today, because again, we're going to be practicing what we started exploring yesterday, but we need to recognize and focus on the fact that, okay, the most important points, by the way, I don't know why I still have people on A and C, you can change your answers, I haven't closed the poll out. The most important points are what again? There we go. Are the zeros or the x-intercepts or the roots, okay? And so we want to keep that in mind. By the way, don't forget, you have your textbook. This is your textbook for all of eternity. You might want to make the note to yourself that you can do these 3 things to help you study moving forward. That's just me. If you don't want to make that note anywhere, that's fine. Just looking in the book. I think a good place to maybe make that note would be under activity 2.2 in that top right hand corner, bottom right hand corner somewhere. But it's important to note we need those zeros, and here's 3 different ways to find those zeros.
What
No.
I'm finna say, what page?
145? Is that right? 145.
You said around here.
I mean, just anywhere you have space on there, it's just noting those 3 things can help you find the zeros, which are the important things. I will note these top 2 are the ones I'm probably going to focus on the most. Or like, those are the 2 I would use most frequently. Okay, so just making that note that you can look at the x-intercepts of the 2 linear factors on the graph. You can set the 2 linear factors equal to 0 and solve for x. Those are the 2 I would probably use the most often. They're going to be the easiest.
So zeros and x-intercepts aren't like the same thing.
What do y'all think? Are zeros and x-intercepts exactly the same thing?
Cause I remember yesterday you was like, not exactly.
Yep. So are they the same thing?
No.
No. Remember, the way you can find the zeros is by looking at the x-intercepts. If you have this x-intercept, 5, 0, what is the 0?
5.
Well, the y value is 0,
5.
but what is 5?
The 0. Oh, the x.
So, x-intercept, 0. This is how we always write a 0.
Cause
What?
the y-intercept gonna be 0.
The y value is going to be 0,
I mean, yeah, well, right.
right? So whenever I'm talking about a 0, remember the y value is 0 and I'm asking you for the x value. That's also a way to write the root. Okay, so that's an important thing to remember. As I said, you can find the zeros from those x-intercepts, but the 0 would be x equals 5. Okay. Alright. Can I get off this, or are we
Yeah.
still writing? Omar, you done? So then say that. But hold up, Mr. Kenner. Alright. Let's keep going with it. So, yeah, I totally forgot to take off the reminder about rubrics. Let's do that. There. Okay. So we're going to finish activity 2.1 to start. And then we're going to get into activities 2.2 and 2.3. One thing I do want to note, I took out the rubrics, but guys, the talking and the active collaboration to help each other grow and learn, and I know yesterday was the first day back from spring break, but it was bad. You cannot grow and learn if you're not actively engaging in the content and thinking through things. You can learn and you can think to high levels and learn through that, but you need to expect a little bit more out of yourself. I'm here to support you in your growth. So remember, we've been dilating functions by non-constant values. The big thing to remember there is, if I take a linear function and I dilate it by another linear function, do I still have a linear function?
No.
So like here, I took a linear, I dilated it by another linear, what did I end up with? A parabola, which is what type of function? Quadratic, right? So when we dilated by constant values, it did not change the type of function. But when you dilate by a non-constant value, a variable, it is going to change the type of function. And a small example of this, I showed this in third block. Nope, that's not what I want. Just so you can see that this is true in any case. If I have y equals the absolute value of x, there's the function, right? If I then take the absolute value of x and I dilate it by x, does it look anything like an absolute value function anymore?
No, that's square root.
No, that's square root. Cube. It looks similar to a cube root, but let's check to see if it actually is. Not cube root, a cube. Sorry, I missaid that. So is it exactly a cube?
No.
No. It's close. It looks similar, but it's not quite. It's actually, if you think about it as x times x, it's in some ways close to x squared or a quadratic. But we're not going to go into why. The main thing I want you to see is, if you dilate by a non-constant, it's going to change that function completely, right? Okay. And notice, all I had to do is test it out to see if it actually was a cube. Don't just make assumptions. Test your assumptions. That's a great question or a great idea, but you want to test what you're predicting. So, and then we're also going to focus on the linear factors with positive and negative. So yesterday we touched here on A, and we actually already talked about this a little bit in the first bell ringer question. It asked us, or this function asked, this problem asked us to look from x equals negative 10 to x equals negative 3. That's where we ended up. And when we looked there, right, y was the product of the linear factors resulting in j of x. Why were those negative?
Because they hidden in the.
Because the y value is increasing.
Okay, y'all are forgetting the whole reason why we talked about it, and it literally says up here why the product of the linear factors results in j of x being negative.
Y equals negative x plus 3, positive plus a negative,
Positive plus a negative.
times a negative.
Remember, the whole thing was that these values are positive, these values are negative, and a positive times a negative gives you a
Negative.
negative, right? So one linear factor had positive values. And you should already have something written here that's close to this, so you don't have to rewrite it, but one linear factor had positive values, and one had negative. So the product was negative, right? A positive times a negative will give you a negative. We're not going to focus as much on why the function is increasing, but I will point out, how do we know that this function is increasing here? Because it's going up, right? Remember, when we're talking about increasing, we always read a graph from left to right. So the x values are always what? They're always increasing, right? I'm not saying that the x are increasing. When we talk about intervals over which the function increases, we're talking about the y values are increasing. That's the thing to keep in mind. So now, using that information, I want you all to tackle 8b within your small groups. Consider the interval between x equals negative 3 and x equals 0. Now I do want to establish, note that's looking here, x equals negative 3 to x equals 0. Does anyone see anything important that we should note before you start talking about this in your small groups? Like why negative 3 and 0?
They both the zero.
Those are the zeros, right? So notice we are looking in between these zeros here. And so what we're asking you to do, remember, is explain why the product of the linear factors results in j of x being positive. Alright? So, talk about that within your small groups. We're going to come back together in just a couple minutes. But I want you to actively think for 30 seconds. Just get some ideas in your head. Silently, no talking yet. After that 30 seconds, I'll say, okay, now talk to your small group. We'll come back together in about 2 minutes total. Let's get to work. Or let's get to thinking. All right, 30 seconds starting now. All right, your 30 seconds are up. You can keep writing for a second, but I do want y'all to start talking as a small group. We'll go over this all together, but I want you to have some ideas about why the product of the linear factors is positive. I need to hear those ideas. Let's get to talking. Kyle, you can't just go every single time I ask you to think. Talk with your small group. Think about what we did with 8a.
I'm gonna say.
Can you explain that a little bit more?
Because how you said that this a negative time could positive give you another negative.
So one thing to keep in mind is originally, can I see your book? Originally we looked at from x equals negative 10 to x equals negative 3, right? So I wasn't looking here and here, I was looking, all of these values are positive and all of these values were negative. So that positive times that negative gave us those negatives. So now we're looking from x equals negative 3 to x equals 0. Continue thinking on that train, but how are we getting positives there? Hold on 1 second, sir.
Alright.
Yeah. Okay. So think about the increasing and decreasing, and if you finish that, move on to 9a and b. What's up, Anthony?
Mr. Kennedy, I said, why the function changing from increasing to decreasing? Is it because of the vertex?
So the vertex is where it stops increasing, starts to decrease. Yeah. What'd y'all say for why these are positive?
Because a negative times a negative equals positive.
Can you hear where that came?
Is that right?
We'll talk about it. What ideas have y'all come up with?
I would think somebody vertex. I ain't gonna go around it.
Did you use our reasoning from A to help you with B?
Nah, I just did the vertex.
Does that make sense if you're not? Remember, math builds. So if we did this, and this is connected to it, that should probably help inform your thinking about it. Jenny, did you come up with any ideas?
What do you know?
If you're this stuck on 8B, why didn't you ask any questions about 8A? That was very, very simple. I cannot help you if you're not asking questions. You're very intelligent. Give yourself a chance.
I don't know how to do nothing wrong.
Yes, you do.
Thank you. Thank you. Thank you. Okay, so let's look at it. Remember, and I need y'all to always keep this in mind, math builds on itself, right? What you do in one part should probably inform what you do in the next part. Previously on 8a, we looked at the fact that this linear function, all of its values were what?
Positive.
Positive. this linear function, all the values were,
Negative.
and we're doing a dilation, so they're being what? Multiplied. A positive times a negative gives us a
Negative.
negative. So, I heard a couple of different reasonings, and I'm going to specifically call on someone who did not give me an answer when I was coming around in a second, so you need to pay attention to the reasoning of others, right, to see if you might agree or disagree with them. So, Allie, what was y'all's reasoning for why all of these values on the parabola were positive?
So negative times, or negative multiplied by negative equals a positive.
Okay? Do y'all agree that negative times a negative gives you a positive?
Yeah.
Or creates a positive? We're all good with that idea?
Mhm.
Okay. But what's your reasoning about this negative times a negative? Where's that coming from? Can anyone add more detail onto that?
The lines that's in the line that's in the purple lines.
The lines that's in the purple lines.
Yeah, those look. Just mark the right.
Can you come up and mark them?
D right here. Oh, D right here.
Okay.
Don't write that.
So,
Yeah.
what are those lines? Because I feel like some of us forgot that important detail. What are those lines right there? Or at least those parts?
Inners.
Well, remember, here's the x-intercepts, right? Where are these lines coming from?
From the linear factors.
Ah, remember, those are the linear factors, right? And what do we do with factors? We multiply. So if these linear factors have negative values, right, and a negative times a negative is a positive, all of these values are
Positive.
positive. Jenny, are you good with that idea, or you got questions about it?
That's what I was trying to say when you were
Okay.
I just couldn't figure out how to put it in words. But that's what I was saying.
Okay. But we gotta learn how to put it in words, right?
I
Like,
know.
if we can, be careful and don't forget, if you can't fully explain it, you don't fully understand it. So we gotta work on our language with those things. Being able to talk about this is important. And so, yeah, we want to notice, right? Both linear factors have what kind of values?
Negative.
Have negative values. And remember, we're talking about the y's in those cases, right? Have negative values. So the product, and why am I talking about a product?
Because it's multiple.
It's multiplying, right? We're dilating one function by the other, but the product is what? Positive.
So product is like the answer of multiplication.
The product is the result of multiplication. Yeah. The product is the result from multiplying.
Like 5 times 5, 25. And
Correct.
The product
So the
is 25.
product is 25.
Alright, bet.
5 and 5 would be your factors that are multiplied to get the product. Okay? So both linear factors have negative y values, so the product is positive, which is why that parabola has positive values there. Okay? I'm not going to focus as much on the increasing and decreasing, but I think, I'm trying to remember, someone told me about that. What's the point that's causing that change from increasing to decreasing?
The vertex.
The vertex, right? Notice this vertex right here, right, is where it stops increasing and it starts to decrease. One of the things I always try to point out to students is it's a curve, so there isn't a line, but if you were to draw a line that touches at just one point, what kind of slope is that right there?
It's a positive.
It's a positive slope, right? On the other side of the vertex, what kind of slope is there? A negative. Okay, what number is in between positives and negatives?
Zero.
If you were to draw a line here at the vertex, anyone know what kind of slope that would be?
Y equals X.
Not undefined. What did y'all just say is between positives and negatives? So what would the slope of this line be? 0. Right? Notice, and that I bring that up because it's important here as well. When we have the x-intercepts, that x-intercept is where it changes from being negative to being positive. And then at that x-intercept, it goes from positive to being negative. Okay? So we want to notice, that's why those x-intercepts connected, or the zeros, are so important. Notice when I look to the right of that zero over here, the parabola has negative values, because one linear factor has what kind of values?
Positive.
Positive. The other one has
Negative.
negative. Right? So we want to notice that that's yielding that product there. What are your questions before we continue? So, I already heard Kyle say, well, Mr. Kinney, I got no clue on the answer for number 9.
Nobody said that.
You literally did, I listened. You might not have been those exact words as that same energy though. So what do you know about the linear function factors when the resulting quadratic function has a positive a value? Well, if you go back and you look at g of x from number 4, or numbers 1 through 4, what we had was x times x plus 3, right? Is the a value there positive or negative?
Yeah, positive.
That's positive, right? Specifically, does anyone know what the a value is? Nobody? Say again? Well, remember the a value determines what the concavity is, but my question is, what is the value of a?
We don't know.
Yes, you do.
One.
Say it again. It's a 1.
Oh, yeah.
It's understood to be a 1 times, right? So that is a positive a value, which, Caleb, that's why when we graphed that function, the parabola was concave up on for numbers 1 through 4, right? Okay?
Yeah.
Why is it positive? Well, this factor, positive or negative?
Positive.
Positive. This factor, positive or negative?
Negative.
Positive.
Where do you see a negative anywhere in here, Anthony?
That's an x plus
But I thought it was horizontal is inverse.
But that's not a. You're thinking about the roots, right? The root, the zeros would be x equals 0 and x equals negative 3, but I'm not talking about roots, I'm talking about a. Remember how it's a times x minus r1 times x minus r2?
Yeah.
Right? So, if I look at the coefficient of x, it's a 1, that's positive. If I look at the coefficient of this x, it's 1, so it's positive. And what's a positive times a positive? It's a positive, right? Is that the only way to get a positive a value though?
No.
How else could we get it?
A negative
Negative
term.
times a negative.
Negative.
So we want to recognize if we have a resulting quadratic function, in order to have a positive a value, either, let's actually answer it completely, to get a positive a value, either both factors have positive, and we probably want to recognize that they're the slopes, right? Positive slopes, or what?
Negative.
Negative slopes. We haven't looked at that case of both negative slopes, but you know a negative times a negative is a positive. Okay, so for numbers 5 through 8, that's where we got j of x equal to, and really came out to be, it started as x times negative x plus 3. And remember, we just rewrote that as negative x times x plus 3. So, hopefully we recognize in numbers 5 through 8 with that j of x, we have a negative a value. Specifically, what is a?
1.
Negative 1.
With 1 negative 1.
Negative 1. We want to notice it's a negative, so it's a negative 1, right? And so, yes, and we even see it right here, the parabola is concave down. But why was this a negative? Well, because we have a positive times a negative, right? That's it. It's logical. It makes sense. We want to recognize here to get a negative a value one linear factor has a positive slope and the other is negative. Alright? The only way to get it negative is to do a positive times a negative. That's it. Omar, I'm not waiting on you since you've waited this entire time to get started. You get as much down as you can. Apparently we are dismissing at 12:10 today, just as a heads up. First block is only 8 to 9:10. Second block will be 9:15 to 10:25. Third block will be 10:30 to 12:10. No after school activities.
So we ain't going to 4 o'clock?
Doesn't look like it.
For what reason?
Severe weather.
What am I supposed to get back to? Dude, it said 3 o'clock.
What'd you say?
They said it was not supposed to get ready for 3 o'clock.
But the issue is buses.
Yeah, they gotta give us time to get home.
Alright,
Dang, you shouldn't have skipped 3 o'clock.
you gotta do third block so we can have lunch.
Yeah.
Okay, so let me ask you this. What are your questions at this point before we move on to activity 2.2?
Nothing, for me.
Say again. That's a good question. So remember, if I have x and negative times x plus 3, if y'all didn't hear Caitlin, she asked, where does the slope come from? So remember, this is the first linear factor, right? And if you were to think about a line, what's the general equation of a line? Y equals mx plus b. So remember, the slope is the coefficient on the x, because that's what's being multiplied. So what's understood to be multiplied by this x?
1.
So it can be things other than a 1, but in this case, that's a positive 1, right? If you were to distribute here, you would see that this is a coefficient of negative 1. So a positive times a negative is how we're getting that negative a value. Does that answer your question? Okay. Anyone else have any questions?
No.
Kyle's good to go. I want to point this out. At this point, we're not asking questions. Hopefully that means that we are actually good to go on this. Is it possible that you forget these details?
Yes.
Yeah, which is why you have to study. Hard work pays off. You cannot sit here and just expect yourself to remember this for all of eternity. You gotta study these things. Make sure you go back and you look over this. It would not take long to look back over this detail tonight to help remind you of all that information. So we gotta get started because we only have 30 minutes left. So I want y'all to notice here, activity 2.2. Not much has changed, okay? We are starting with a linear function. What is f of x, the linear function here?
X minus 1.
F of x is what?
X plus 3.
X minus 1. Yeah, f of x. X minus 1.
Oh, X minus 1. Oh.
Okay? Now, I want y'all to pay attention because if you don't notice this next detail, a lot of this becomes very difficult. What is the scaling on my x-axis and on my y-axis? my scaling, every block is how many units?
Oh,
It's how much? No. I see why you think that, and it's not 13. I'm asking each individual block is how long?
One.
You think it's one?
two.
Oh, 2 units.
Oh,
We need to recognize
So
And-
do you skip or you just go?
you
to
going
the
by
line?
2, 2, 4, 6.
it's scaling by twos, but what you need to recognize is, so right here, you see how it intersects right there?
Yeah.
So what do you think that point might be?
1.
No,
Okay.
no.
So basically it just zoomed out.
Well, it's gonna help us because we need more space, but I also want you to notice, hey, what would be my root or my zero for this linear function? 1 comma 0, right? Would be the x-intercept, x equals 1 would be the 0. Oh yeah,
Why is that point 1?
Because.
what's halfway between 0 and 2?
But, oh, okay. I forgot.
Right?
It's bound by 2.
It's scaled by twos, and that's my point here, and you need to pay attention to that. Because again, what are the most important points when we're dilating like this?
The 0.
0.
The zeros. So we really need to focus on those zeros, right?
Yeah.
Okay. Now, in number 1, it's asking us to dilate the function f of x by a factor of x plus 3. So notice, we're going to get m of x, and we're going to rewrite this in a second, but m of x is equal to x plus 3 times f of x. Any questions there? Or what are your questions there? Good.
Do you just add the 3 on the end and make it 2x plus 3? I mean plus 4? No,
What do y'all think?
So are
plus
you?
2. I don't know.
So the equation is m of x equals x plus 3 times f of x.
And
And
f
you
of
have to figure out
x
which
equals
one, I mean, the points for
X.
the m of x and f of x.
You already have f of x. It's that graph right there, right? So I want to leave it up to y'all, and I want you to ask y'all this question: is Anthony correct that we're just going to add x plus 3 and x minus 1?
No, you gotta multiply.
Okay. It's multiplying. Like that's all there's to it, Anthony. So you need to recognize, and there's a couple of things to keep in mind here. We already have this one linear function, right? Could you also graph that one? Okay, that's an option. I will also remind you, hey, we already said that we need the zeros. Anyone know what the 0 is for x plus 3?
Negative.
Negative 3. So this again, you have to keep in mind the scaling. That's negative 1, that's negative 2, there's negative 3. So what should I be focusing my attention around?
That negative 3.
That negative 3 and that 1. So keep that in mind.
Negative 2.
From there, remember you can do this either graphically or what other method did we
Table.
use yesterday?
Table.
A table. So the 2 quick things I would point out is, what this is literally saying, because yesterday we just did x times f of x, right? So we took the x value and we multiplied it by f of x. Is it just x this time? No. It's the x value plus 3. So when I look maybe at this point, so I'm just going to look at that one right now because notice that's in between my zeros. That's the point. First off, what is that point?
That's 2.
That's not a point, but
Which point?
negative 1 is the x, negative 2 is the y. So remember, what this is literally saying is multiply y, right? That's what f of x is, by the x value. What's happening to the x value though? Plus 3. So, by the way, I'll point this out, Anthony. Do I multiply first or add first?
You multiply first.
Multiply first. Wait, what?
No, multiply.
You add first. That's inside of parentheses, isn't it? We go with the idea that parentheses are telling us to do that operation first.
Yeah.
So, you can do this just graphically. What is that x value plus 3?
2.
2, right? So if I take the x value and I add 3 to it, I get 2. What's 2 times the y of negative 2? Negative 4. So the x value is negative 1, the y value is negative 4. Now, I would not crowd my graph too much with writing points out like that, but there's the point for my new function m of x. That's all you have to do. If you recognize that I'm taking the x value and I'm adding 3 to it, and then multiplying it by y, you can do it just on the graph. But again, what could you create?
Table. That's gonna be easy.
If that's easier for you, go for it. I don't care which one you do, I'm giving you options. The one thing I would point out is we need x, and what's a good x value maybe to start with? Should I go all the way over here to negative 16? No, why not?
Because it ain't even on the graph. I mean,
I can figure it out.
that's hard.
Negative 4 might be a good one, why?
Cause if you do higher than it,
Say again?
if you go to height, like if you was to do 16, you'll be all off the graph.
I mean,
It's not a good starting
sure,
point.
but why not? Y'all are forgetting the opening discussion we had today. Where should we focus our attention? Say it again. The zeros. Right? So we said from the very beginning. So I have a 0 here at negative 3, so maybe a negative 4, maybe even a negative 5. Just outside of that 0, a couple outside. So maybe an x value of negative 5, then negative 4, negative 3. What would be a good x value to stop at?
Well, for yours.
Like,
Not necessarily a 5. I would say a 2 or a 3. Why would 2 or 3 be a good x value to stop at? You're just making assumptions instead of thinking about what we specifically said are the points we need to focus around. The what? The zeros, right? I don't need to go all the way over to 5. My zero's right there, isn't it? So I'm just going to go 1 or 2 to the right of that 0. Does that make sense? And then you need f of x. What else for each of those x values? What else do you need?
What you need?
I mean, I'm dilating f of x by something, so what else do I need to dilate it?
the y.
That is the y. Well, I'm trying to get m of x. But remember, to get m of x, I am dilating f of x. By what? Not just plus 3, what plus 3? X plus 3. Right? So you need f of x, and you need x plus 3, and you're going to dilate them to get m of x. I'm going to give you all a couple minutes to try to get started on each of those things to help you. Do not forget, right, it's x plus 3 here. It's just x minus 1. That's what f of x is. You also have the graph for f of x. But I'm going to give you a couple minutes to get started. If it looks like we're still struggling,
Can you give us
and
the
we're
first?
genuinely putting in good effort, then I'll come back and help you out as a whole class. If you're not trying, I'm not coming back to have a whole class discussion.
Can you give
put
us the
in
first
your-
one right quick, Miss Henry? The first f of x.
No. X is your input. F of x is the what? Output. You have both an equation for f of x, and you have a line for f of x. You can use either one of those to get your output. Think about it. Alright? Talk about it within your group. Help each other figure out what those outputs would be. If we're putting in actual good effort, as I said, we'll come back and have a whole class discussion. See how you're able to figure it out, Anthony?
Yeah.
Mm-hmm. No, sir.
So we gotta.
Remember, f of x is this line here. You're adding 3, which is the x plus 3. Okay? So, literally, right, to get x plus 3, you're just taking the x value and adding 3 to it. But that's what x plus 3 is. F of x is x minus 1. or this line here.
So,
Use that to help.
since you have to add 3 to the x first, why don't you switch these? Because you're gonna be adding 3 to this column, right? So you can put them right next to each other, just so it might, lessen
So
some
boom.
confusion.
Let me show you one thing to help you make this even a little bit easier.
Negative 5 plus.
X of negative 5, so
Right,
negative
so
2,
that's
negative
what-
4, negative 5 is right here, right? Here's the line. What's that y value?
I know you're supposed to do
Negative
that.
6. Remember, this line is the graph of f of x equals x minus 1.
Well, go ahead and do this
So
one.
can I just go to this graph to get the y value?
So,
Notice the next x value is negative 4. It's negative 2, negative 4.
where's the f of x?
There it is.
No,
What's this y value?
I just put it on here because.
You just have to remember it's scaling by 2s. So negative 2, negative 4,
M of x is,
negative
you're
5.
gonna multiply this column
Right?
by this column.
Don't forget to look for patterns that
You
might
have to
help you
find
out.
this.
This first, yeah, okay.
So
How's it gonna
this
be?
one's based off of this one, and then this is your, the
It's
f of
literally
x
just- Huh?
is it the line up on there already? Is that your f of x?
Well, what does it literally say? It says
Okay.
what plus x plus 3. So you need to take your x value and add 3 to it. Does
Okay,
that make sense?
so then what's your
That's
f
it.
of x when you're, it's saying when your x is negative 5,
Right
what
here.
is the output
What does it say?
for the f of x? So it's
X
saying,
plus,
if this is your f
So
of
I'm
x
taking my x
line,
value and adding 3.
wait, we gotta get this value first. We have to find, wait, this is your f of x, the black line, right?
So
And
now.
this is, and what's
So,
the output of the
notice,
black line?
because
When x
f
is
of x, that was that
negative
line, and you can do it that way, but
So
literally,
where's
this is
negative
just x
5?
plus 3. Right here, what's your x value?
So just plug in,
Yeah, it was basic.
plug in your number for it.
Alright.
You
what's
can,
the y?
but also like, so yes, you do that, but also just literally remember, what does it say? It's taking the x value and doing what to x? Adding how much?
No, what's the
By
y
3. So what's
value?
negative 5 plus 3?
When x is negative 5, where's the line crossing? The y value is f of x.
So that's the first one.
Because remember, this f of x, this black line represents a whole.
Y'all all good with those first two
It has an
columns?
input and output value.
Okay.
So when your input's negative 5,
Then I erased it because I completely
what's
ran out of
the
my
output?
network. Like a
Gotcha.
big jumble
I
on my
gotcha.
page, so I had to.
So what are you gonna do to get m of
No,
x?
not changing nothing. Does it have an equation for f of x, or it just has the line?
It's the product, right? We're dialing.
Well, if your x is negative 5, what's negative 5?
So remember, right here, it was x plus 3 times f of x. Here's your x plus 3 value, here's your f of x value.
Negative 5 minus, okay, so
That
that
makes
will
sense.
go
Because I was
here.
looking at this for a
So.
second.
Oh, yeah, we're
So
still on
now
number
what I'm
1, not on number 2
saying
yet.
is, let's look for negative 4,
No, it's
is
dialing.
the output for negative 4.
Yeah.
That, or you can look on the graph and you go to negative, but, no, but listen, they're the same thing, because look, when you go to negative 4 on the x,
F of x, yeah, What's weird, it looks like Jenny and Anna both have it.
because that's the output. So negative 4 minus
Talk it
4
out.
minus 5, so is this at minus 5?
Because Eli might be able
See
to
how they're the same thing?
give insight
I
if
guess
he
this
push
graph
back on it if he thinks
because they're
something's
counting by
wrong.
twos.
We'll come in and answer questions.
Talking about one, it's a lot easier to be like, here's my y, or here's my x, put my pencil down, see what the y value
So do
is.
you negative 5?
Okay, so now for this column,
Down.
you're gonna be multiplying what?
Now, you already have the one right here. When x is negative 5,
Well, m of
y
x,
is
m of x is equal to what two things?
I'm just trying to.
negative 5, 12.
Times
Not
what?
negative 3, 12.
Oh, it look like space.
No.
Okay, so m of x is equal to x plus 3.
You touch this, remember this, yeah, it's scaled by 2. So it's 2,
Yes.
negative 4, negative 5.
Yes.
2, 4, 6, 8,
Okay.
10,
Does
12.
that help? Did that help you a little bit?
Alright, so then.
You can use, for this one, might be a little better use get that equation for your f of x, if you're having trouble finding the.
Oh,
Yeah, you were
So you're-
revising your x.
Yeah, so, x plus 3. Right, to get that answer.
Negative 2, negative 3.
No.
So, this last column,
Okay.
oh, I see, sorry. Yeah,
You kind of did, but you have it mixed up, so D is supposed to be your line.
one of your numbers.
Yes, D is supposed to be your line too. So you add 3 to D.
This one, so it's 0
That's how you
and
get
then
your answer to it.
negative
Then you just
3.
multiply this
And then -2. So you have 2 negative 2s.
I'm-
Just fix that one. They're right. You understand how you got those?
Oh.
Points?
Okay.
You see what I'm saying? Because this is the
Negative.
-4 times -1.
So,
Wait, sorry. -4 times 0 is 0.
Okay,
-3
yeah.
times 1 is -3. That's what I'm saying. Does that make sense?
Yeah.
Okay, but yeah, you
Two negative three.
you did all that, it's fine. Do you understand how you like got
But what I
those?
told you, was you talking about this?
okay, yeah, I was gonna write that. Could explain.
Or no, this one. Just how you get them numbers.
For the second line, because it's, yeah, I see.
Mr. Kennedy, you got 1 point as -2, -3. Alright, so but they interclave. They connect. I mean they don't connect. Like
Let's talk about it. Thank you. So from what I can tell, we're okay with creating that table to make sense of this. Does anyone have any questions about the f of x, the x plus 3, or the m of x values?
No.
Got one who's good.
No.
I'm straight.
Anna, were these the values that y'all had for f of x? Okay. So I want to remind you, if I can get everyone's attention please, really quickly. Literally, f of x was just x minus 1, wasn't it? Okay? So two things to recognize about that is, I'm just taking the x value and doing what to it? Minus 1. -5 minus 1 is -6. -4 minus 1 is -5. You can also have just looked at the graph to find it. Once you get a couple of these, we do want to recognize what's the pattern that we should have seen here. It's adding 1. Because, hey, what's the slope of this line? The slope. The slope is 1, right? 1 times x. Remember, a linear function has what rate of change? Constant additive, thank you. And Eli, what mathematical operation shows repeated addition? Multiplication. This multiplication is my slope, that's my constant additive rate of change. What's that -1?
Wouldn't that be the y-intercept?
That's the y-intercept, notice that's right here. So we want to notice that. The one thing to keep in mind and be careful with is, we had to use f of x and x plus 3 to get m of x, but this is the x value, that's the y value to graph those points. And again, you're scaling, or the graph is scaled by 2, so you have to be careful with that. So -2, -4, -5, 12. There's the first point that we can fit. And you could have gone beyond that, it just wouldn't have fit on the graph. So -4, 5, 2, 4, 5. -3, 0. Which makes sense, because that was one of my roots. -2, -3. Notice, Anthony, we just have to keep in mind that it would be in between the -2 and the -4, about halfway in between, that's it.
yeah, I thought it was gonna make a linear function.
I think it's -1, -4 for the next one. Why would it make a linear, bud?
No, I don't know, cause I thought it was the second cause you feel me, two linears gonna equal a parabola.
A parabola?
Yeah,
Yeah, so not a linear?
huh?
So not a linear?
No.
Okay, then you just defeated your own argument.
No, I'm saying, you know, on the other side, we had two of them lines, linear factors. We had two of them.
I'm pretty sure we have 2 here as well.
Well, we only got one.
Well, there's x minus 1, right? And what did we dilate it by?
Oh.
So that was linear, and this is,
linear.
oh,
We just ain't plotted.
we just, well, yeah, we didn't graph the x plus 3 yet.
Okay. Alright. Yeah, I still got a parabola though. Then I just gotta get that out
Which I should have told you something.
there.
The only way to get that parabola is the product of 2 linears. Okay? So from here, what we want to recognize is what would the equation for m of x actually be?